This is the 10th lecture in our review series before we start diving into Algebra 1, and today's topic is equivalent fractions. So to demonstrate equivalent fractions, I'm going to simulate here a pizza, a nice round, perfectly round pizza. My circle drawing is not very well, but that doesn't matter. You can still see that this is a pizza. And if I cut the pizza in half, let's say I cut the pizza in half and I consider half the pizza. And to do that, I'm not going to waste my ink. I'm going to use this pencil here so that we can kind of still see that we're talking about half the pizza. Okay. So I have half a pizza. And of course that fraction is 1/2. Okay, so let's say that I cut the pizza again, and now I have 4 equal slices of pizza. Do I have 2/4 of a pizza, or 1/2 of a pizza, or both? Well, what did I do? I doubled the total number of pizzas, so I doubled the denominator, and I doubled the number of slices that we're considering. We had 1 because we had a half, and now we have 2, so I doubled the numerator. And then that gave us the result. When we multiply fractions, we multiply across the top, and we multiply across the bottom. So now we have 2/4. So what is this? What's special about this number here? Well, 2 divided by 2 is 1. So I took a fraction, I multiplied it by 1. Well, any number multiplied by 1 is the same number. So all I really did was make another fraction that is equivalent to what we started with. And what we say is 1/2 and 2/4 are equivalent fractions. Two fractions with the same value. Formed by multiplying by 1. So, let's say I want to split the fraction into more even slices. Split the pie. Okay. So now we still have a half a pizza, but we have 1, 2, 3, 4 pieces shaded out of 8. And if I start with the original fraction, and now that I have 4, you can see that that's also equivalent to 4/8. Okay. So to find another equivalent fraction, we multiply the fraction by 1 in the form of a number divided by a number, provided that the number is not equal to 0. We can't divide by 0. Okay, so in other words, maybe I want to divide it again. What if I want 16 equal pieces of pizza? How many? Well, 1 times 8 is 8, and 2 times 6 is 16. Okay. So these are all equivalent fractions. Let's look at 3/4. What's another equivalent fraction of 3/4? Well, we could take 3/4 and multiply it by 2 over 2, which is 1. And 3 times 2 is 6. And 4 times 2 is 8. So 6/8 and 3/4 are the same. What's another way we could do it? How about 2/3? We could say 2/3. We can multiply by any value of 1 as long as the numerator and the denominator are the same. And they're non-zero because we can't divide by 0. This would be 20 over 30, and 20 over 30 is equal to 2/3. Okay, now, if the numerator, or the top of the fraction, and the denominator, which is the bottom part of the fraction, if the numerator and the denominator have no greatest common factor other than 1, and we studied greatest common factor in the last so if the greatest common factor of the numerator and the denominator is 1, then the fraction is in simplest form. For example, 1/2. We can't even find the prime factorization of 1. So if 1 is one of these, then you know that the greatest common factor of 1, and the prime factorization of 2 is 2, and they have no common factors. 1 and 2 have no common factors, so we say that 1/2 is in simplest form. Now 2/4, 2 is just 2 because 2 is prime, and 4 is 2 times 2, and the greatest common factor is 2. So the greatest common factor is 2. 2/4 is not in simplest form. However, to reduce a fraction to simplest form, we divide the numerator and denominator by their greatest common factor. We divide the numerator and the denominator by their greatest common factor. So here, and you can even see it without dividing, if we have 2, which is 2, and 4, which is 2 divided by 2, and I divide this out, I'm left with 1/2. Okay? So you don't even really have to divide. You can just multiply what's left after you circle out the greatest common factor. Let's look at an example. (12 over 16). Okay, so 12/16. Okay, 12. I'm going to go ahead and do the prime factorizations. You can do these on your own. 12 is 2 times 2 times 3, and 16 is 2 times 2 times 2 times 2. Now, you can see that the greatest common factor of these is 4. Okay, but I'm going to go ahead and put these as like in a fraction form here. So if I divide 12 by 4, I get 3, and if I divide 16 by 4, I get 4. 3/4. But if you look at this, after I take these out, what's left? 3 over 4. So you can skip the dividing step by just looking at what's left in the prime factorizations when you figure these out. Now, to prove two fractions are equivalent, you find their cross products. If they are equal, if the cross products are equal, the fractions are equal. For example, 12/16 is that really equal to 3/4? Okay. And you start at the bottom. Always start at the bottom, and I'm going to show you why in just a minute. 16 times 3 is 48. 4 times 12 is 48. They are equal. So the cross products are equal. 2. Starting at the bottom, and multiplying diagonally. So if you start at the bottom and multiply diagonally, the smaller value is the smaller fraction. The smaller value is the smaller fraction. We already know that 1/4 is less than 1/2. But let's prove it. If I start at the bottom and I multiply diagonally, 2 times 1 is 2, and 4 times 1 is 4. 2 is less than 4, therefore 1/4 is less than 1/2. Okay, so let's look at some examples. We've seen several of these. Let's reduce some fractions. And in some of the classes that I've taught, we've reduced some pretty big fractions. We're not going to do that today, but let's reduce 24 divided by 24/42. Okay, so 24 is 8 times 3, and 8 is 2 times 2 times 2 times 3. Again, I'm not really going to review the prime factorization section of this, so you can do this on your own. 42 is 6 times 7. 6 is 2 times 3 times 7. So we get this here in common and this here in common. So the GCF is 2 times 3 is 6, and what's left? 4/7. So 4/7 is this reduced. Are those equivalent? Yes. 7 times 24 is 168. 42 times 4 is 168. Okay, so those are equivalent. Let's look at another example. 3/4 and 7/9. Are these equal? And if not, how do you compare them? We'll just compare. We'll call it compare. These two. So we start at the bottom. 9 times 3 is 27. And 4 times 7 is 28. So 27 is less than 28. So 3/4 is smaller than 7/9. Okay, so that covers equivalent fractions. In the next lecture, we're going to really dive into decimals, fractions, and percents, and compare and contrast these different forms of the number. I look forward to seeing you then. Thanks for watching.